We built a complete MERN application with all 4 technologies involved, obviously. Now it's time to not just test it locally, but instead to also deploy it. So to move the application onto a real server where other users can reach it as well. Because at the moment, of course, it only runs locally on localhost, which means only we can see and use this application. Therefore, in this module, we will have a look at the steps we should go through to prepare our application for deployment and some things you should keep in mind and you should have a look at when you want to deploy your application. And then I will show you 2 different ways of deploying MERN apps you could use. So 2 different ways of getting your MERN app onto real servers. So let's dive in. Let's start with the preparation steps we should go through before we actually move our code to some server. Now, the first step is the obvious one. We develop our app and we test our code. And we did this throughout this course. We continuously added features and we always tested this. And of course, you want to really test different scenarios, also test with different users, on different devices maybe, and also what was not the focus in this course, you of course also want to ensure that your scripts and your CSS code works across a broad variety of browsers. But the exact steps there really depend on the kind of application you're building. So let's assume everything works fine there and we're happy with the result we got. Well, then we want to move on to the next step before we actually move our code to the servers. We want to swap our URLs, which point at localhost or anything like that, for real URLs, which point at a backend, so to the server where our app really is hosted on. And we also want to make sure that any credentials or API keys we're using in our code, both on the backend or the front end, are prepared for deployment so that they are production ready, that we maybe locked down access to certain IPs or whatever we want to do there. And we want to look into environment variables there, and we will do so here in this course, so that we can easily swap certain values for testing locally and for deployment. So you will see how we could do that in this module. And once all of that is done, we want to build our application, most importantly our front-end application, which means we want to build the code, optimize it, and bundle it to have as small of a code as possible, and then deploy it to a server. And once our application is deployed, of course the work doesn't stop. Thereafter, we want to test this deployed application as well and check that everything is working. And of course, even once your app is up and running, you want to monitor it and maybe adjust it, bug fix, and so on. So let's now go through these steps and ensure that by the end of this module, we have our application running on real servers. So back in the app we worked on, again, I have my backend opened in one window and frontend opened in another window. Now, in this project here, we want to have a look at the different API keys and URLs we're using to ensure that we can use the same keys and same URLs once we push our app onto a server. Now, let's start here on the backend. There, I got a couple of values which I might want to swap between development and production. Most importantly, if we go to the app.js file, there we connect to MongoDB with a certain user, a certain password, and a certain database. Now, it's not unlikely that we might want to use a different MongoDB Atlas account here, a different database, so different values for our app that runs in production than we do for our app that we test locally. The database should definitely be a different one so that we don't interfere with the data of our real users if we then continue working on the app locally in development. So if we then add new features, add new dummy data, and we mess with the database our real users are writing to as well. We don't want to do that. So it would be nice if these values, username, password, and also the database name, would be kind of variable. And depending on whether we run this locally or on a real server, we insert different values there. Now, thankfully, that is something we can do without too much effort. Locally here, I am using NodeMon, right? We're starting app.js with NodeMon. Now, we can add a nodemon.json file to provide some configuration to NodeMon. Now, you can check out NodeMon's docs to learn all about the configuration values you can provide there. This should be a JSON format, and here, I'm interested in the nth key, which we can set up there. Nth for environment. And there we can set up so-called environment variables. These are variables, variable data, which depends, or where the values depend on the environment you're running in. And you can refer to them in your code, and therefore, based on the environment your code is being executed in, you will be using different values in your code. Env in the NodeMon config takes an object, and now there you can have any names, any keys of your choice. For example, db user. You don't have to write it like this. This can be any name of your choice. And then you enter the value here. So here I will actually stick to this value, and I will use Academind here as a user, and hence enter this here between double quotes on the right side as a value. I will also store my password here with db password. And then here, go back to app.js and grab that password and copy that into nodemon.json. And then also the db names, so the database name. Here, I will use MERN because that is the value I'm using here too. Now, these are my development values. You might wonder, where do we enter the values we want to use in production, so when our app really runs on a server? Well, that depends on the hosting provider you're using in the end. If you're using some service that does all the general setup for your application, as we will do later, then this service will give you an easy-to-use way to provide such environment variables. And I will come back to that once we really move our application onto such a real server. So you will later see how to configure values for the production mode as well. These are our development mode values, and now we just have to refer to them in our script, of course. Now here, I'm already setting this connection string as with backticks so that I can dynamically inject values. If you're not doing that, make sure you do so. And with that here, we can inject the value instead of the hard-coded username. We have to refer to process.nth and then the name of your environment variable. So in my case here, db user. This process.nth thing is something Node.js provides to you. There is a global process variable, which is always available. It has an nth key, and this gives you access to the environment variables that are injected into the running Node.js process. And NodeMon injects these values, and as I mentioned later, when we run this on a server, different values will be injected. So with that, we can refer to a value for the user, here then also for db password, and then here at the end, instead of this hard-coded database name, it's db_name, which I chose here in NodeMon.json. So with that, we're injecting dynamic values here. Now on the backend, I got two other things I could inject, and that for one is in the util folder, my Google API key here. We might always want to use that. In that case, we could also hard-code it here. But if we want to use a different key for local development and for running this in production, which is not unlikely, then we might want to inject this here or get this from our environment variables as well. So here we could then refer to process.nth Google API key, or however you want to name it. And now you just have to provide such an API key here in nodemon.json. Now the concrete value is something I will come back to because I want to tweak that API key, or at least have a look at it in the Google Developer Console before we actually use it again. So I'll just enter a placeholder here. We'll take care about the actual value soon. And one other last place I want to replace with an environment variable on the backend here is my private key for the JSON web token. In the user's controller, when we create a web token, I use this private key here, right? Now we can definitely hard-code it into this file like this, but of course keep in mind that we are reusing it multiple times. We're using the same key here in sign up, and then also here in our check auth middleware. Hence, alone from the code reusage perspective, it would make sense to outsource this or to store this in an environment variable. So here I will add the JWT key and store my key in there without the single quotes. And of course, this can be any string you want. And again, you could be using a different string for local development than you do for production. This might be a good idea because if you push your local development code to GitHub or to some public repository, you might want to ensure that you're not using keys here, which you also use in production. Though if you are pushing your data to a public repository, you might in general not want to include this entire Node.js file in the repository because it contains a lot of confidential data. But if you would push it, it's still better to have different values for development than you do have for production, so that at least your production environment is safe. Well, and now with that, we can again inject this JWT key. So in checkoff here, where I need that key, I can use process.env.jwt key, and of course do the same in the user's controller whenever we use that private key. So here in sign up, and also if we scroll up a bit, that was login, also if we scroll up a bit here in sign up now. Now with this, if I start that, I get an error, db name, yeah. Here in my connection string, of course, it always has to be process.env.environment variable name. So with that fixed, if I now start this, it should start again. It should connect to the database. That should all be working. And with that up and running, let's next have a look at the front end before I then also come back here to this Google API key thing. On the front end, we also can work with environment variables. There, of course, we're not using NodeMon, but you can simply add a new file, .env, and this file will automatically be used by the configured build and development process we're using here. This is a create React app project in the end, and the React scripts package, which is used under the hood, picks up such a .env file automatically. And we can use the .env file to also store data we need here on the front end. So which environment variables could we use here on the front end? We could use one environment variable for this Google API key we're using in the index.html file in the public folder. And I think we got one other environment variable that would make sense, and that is the URL we're sending our backend requests to. Here it's localhost 5000, and not only are we duplicating this code everywhere where we are sending a request, this of course will not be the correct URL once our application is deployed, because once the Node application is on a real server, it will have a real IP or a real domain attached to it, and therefore this will then simply no longer be correct. So there are two environment variables I want to add. And now here's one important thing. Your environment variables here have to start with React app, all caps. React app underscore, actually, all caps. For Node.js, for the backend, this was not required. You could use any names here. For the frontend, this is required. Also keep in mind that, of course, the frontend code, as you will see later in this module, will be built locally on our machine, and then we just upload the build files, so the prepared HTML, JavaScript, and CSS files to a server. This also means that you must not have any confidential data in your code. So also here in your environment variables, whatever you store here, when you use it in your React code later, everyone can read and see it in the deployed application because it's not running on a server, it's running in the user's browser. So therefore, never store any confidential data in your React app, no matter if you're using environment variables or not. So with that, however, here we could store our React app Google API key. And now you simply set a value here in this file by adding an equal sign and then right thereafter, without any white spaces, the value you want to store. So it looks a bit different than in the NodeMon JSON file. Here we had a JSON format. Here it's just a simple key value pair file. And in a new line, I will add another environment variable, and this will be my backend URL. And now here, during development, that will be localhost 5000/API, let's say. Later, we can swap this for a different value in production. So with this, we prepared the two environment variables. How do we inject them? We get two different syntaxes. I want to inject my Google API key in the public index.html file. There, if you want to inject an environment variable like this key here, you do so by adding percentage signs at the beginning and end, and in between you reference your environment variable name. So React app Google API key in my case here, or whatever value you defined here in this .env file. This should go in here, and it has to be between two percentage signs. So that's how we add an environment variable in the index.html file. In our JavaScript code, we use them in a different way. We use them just as we would use them in Node.js. For example, in newPlace.js, here I want to replace this part now with my environment variable with this React app backend URL environment variable. And to do so, we use process.env again. So the same syntax you know from Node.js. And then simply, well, add your part of the URL, which is dynamic. So this is how we can refer to the backend URL here. And with that, I will quickly search for localhost 5000 in my project here to replace all occurrences. For example, in place item, here I will get rid of this part. Always also delete /API, because in my case at least, I included that in the environment variable. So that's my correct URL now. Here for the image, it's the same. There, however, and that's a little mistake on my side, I don't need /API. So I will add a new URL here, React app asset URL, because we could theoretically also upload our images to a totally different page. So I think it makes sense to store this in a new environment variable. And now I will use React app asset URL here. So $, React app asset URL, and of course access this on process.env. And with that, we make sure that we are able to access the URL where our images are stored. Remove the trailing slash here in the environment variable file though, because I do have this slash here. Now let's move on. Here in update place, I do send a request, so let's remove that part, including API. And instead inject it here, process.env React app backend URL was the URL I was using. Same here. Let's replace this part here with the dynamic, or with the environment variable part to be precise, like this. In user places, it's the same. Let's replace that here with our API. For avatar image, it's again our backend asset URL. So here I will use my other environment variable, process.env React app, and then the name was asset URL. So here asset URL like this. In off.js, let's get rid of this here. And instead, again, use process.env React backend URL and combine this with the string. In off.js here, it's the same. Get rid of this part, combine it like that. And in users.js, the same. Get rid of this, combine it like that. So with that, I ensure that everywhere in this application, we are able to conveniently control the backend URL through the .env file here and the Google API key as well. Now, of course, we still have a couple of unanswered questions at this point. How can we provide different values for production here in React's and Node's case? And what do we do with that Google API key? Well, let's start with the Google API key before I then come back to that whole production values thing. Before we build and deploy our application, I want to spend some words on the Google API key we're using, and also about MongoDB Atlas thereafter. So here I logged in with that Google account, which I used to create that Google API keys we're using on both the backend and the frontend. And I also made sure that I selected my project here, which we created earlier in the course. Now here under credentials, you will see your API key. And you see that API key I used in the frontend index.html file and in this util folder, the location.js file on the backend before. Now this key can be configured. If you click on it, you can configure where it can be used, so which apps can use it. Now here it is open to everyone, and maybe that is fine for you, but you should be aware of the fact that you can configure it. You can, for example, control which applications running on which HTTP referrers or IP addresses can use this key. And if your key is getting used on any other location, so on any other server, it won't be able to communicate with this Google service. And that might be something you want to do to lock down your key to the IP address your app is getting hosted on in the end. Now, since we're using the key both on the front end as well as the back end, if you're hosting your two applications, front end and back end, on two different servers, which is something you could do, you want to add all IP addresses of both the front end and the back end server. Otherwise, if everything is getting served from one single server, adding that IP address is the right thing. Or you add the HTTP referrers here. So there you enter the URLs on which your frontend and backend will be hosted on. So that is something you could consider. I will pick none here, but it is something you definitely want to be aware of. You can also restrict your key down there. You can restrict your key regarding the APIs it can be used for. And in our example, we're really only using the geocoding API and then the maps JavaScript API. So you might not need the other APIs, and locking it down ensures that if someone else is somehow able to do something with your key you don't want, that at least it can't use it for any API. So that is something you could consider as well. So in general, just consider locking down your key to IP addresses, to domains, and or to specific services that can be used. Now maybe you also want to have two different keys, one which is really locked down and one which is relatively open because only you know it because you only use it in development and you never share it with someone else. Keep in mind that if your key is part of your frontend app, everyone can see it, so that already counts as sharing. But if you only use it locally for development, you could create a new API key which is relatively open, which you use during development, and a different key for production, which is locked down. And to simulate this, I will create a new API key here, which is getting generated. And now I could restrict this, but I will keep it open. But now I have two different keys here. And now let's say this is my development key, the first one. Well, then I can grab this and go back to my code and use this here in the front end for my React App Google API key, and also on the back end for my Google API key. I can insert this here. And later I will show you how to use different environment variables for production, and then we could use this second locked down key. Now speaking of locking down, let's also have a look at MongoDB Atlas again. You learned how you can configure it, how you can control the database and network access, and I want to come back to that. Of course, you could create a brand new cluster for your production project, or at least you create a new database in the collections here, which you use for production, which is what I will do here, MERN prod. And in there, I will add a places collection and thereafter also a users collection so that we have all these collections already prepared. So let me quickly do this here, users. But besides this setup, which absolutely makes sense, but besides this setup, you also might want to revisit your database and network access settings. You might want to consider creating a new user specifically for production because you want to give it different privileges or whatever you want. It's not something I will do here, but you could easily do that. And then since we manage our user on the backend here through environment variables, once you know how you can provide different values for development and for production, you can easily swap your credentials here, not in this file, but for these variables, to use different users for development and for production. Now for network access, you want to ensure that, of course, this MongoDB Atlas server is not just open to your local IP address, but that later, once we deployed our application to a real server, you add the IP address of that server here. Now we'll come back to that once we did deploy our application. For now, we can ignore this. And with this, we're generally set. We added the environment variables. Now let's learn how we build our React application for production to optimize and minify the code to get as small code as possible, how we can provide different values for production, and how we can do the same for the backend. So, a lot of talking about environment variables and keys and so on. Let's now build our app for production. And what does this actually mean? Well, for the React app, for the frontend, you have to keep in mind that this will run entirely in the browsers of your users. Here it is running locally on localhost 3000 during development, and everything we do here is of course controlled by a script which in the end is downloaded. When we reload this page here and we go to the network tab, we see there are a bunch of HTTP requests, and for example, this bundle.js file and this zero-chunk.js file, this is in the end our React code, which is getting downloaded from the backend. So all the React code runs in the browser, and everyone there can see it. You can access it through the Sources tab, through the Network tab if you inspect the responses of the requests, and so on. So this is not hidden code. So since this does run directly in the browsers of our visitors, we have two important things to keep in mind. For one, we of course, as I mentioned multiple times, need to ensure that we have no confidential data in there. Our API key here is fine, but we might consider locking it down as I showed it to you in the last lecture. The second important thing to keep in mind, of course, is that we want to make this code as small as possible, because having smaller code simply means that our users have to download less, and hence the application starts up quicker, so we simply provide a better user experience. Now for that, we have a convenient script. npm run build, if you execute this, will build your application. And whilst during development your code is not optimized, it has a lot of debugging, supporting code in it, when you run npm run build, everything which is not necessary will be stripped out, function and variable names will be shortened, and you will get as small of a code bundle as possible. So let's run npm run build here in the front end, and let's wait for this process to finish. Now once this did finish, with this message here, you also get some metrics about the sizes of the different bundles it produced, and you will find a build folder, a brand new build folder, which contains all the files you would in the end deploy to a backend. These are in the end the files that you want to push to a server. Now, we're not entirely there yet though. For one, we didn't swap our variables here for the values we want to use in production. So that's not great. We of course want to do that, right? Otherwise we have a problem here. The second problem we have is we didn't really prepare our app entirely for production. In the public folder in the index.html file, you can revisit some settings there. For example, set a different description of your web page as it will appear on Google search, for example. Check all these settings in general. Make sure if you want to use that fav icon or if you want to provide your own one. You can also delete this manifest.json import file here and also the manifest.json file if you want to. If you're building a progressive web app, you might need that. Otherwise, it's up to you if you want to add this or not. So once this is done, the rest of this file should be fine. Let's focus on the environment variables. To provide different values for this production build, so for building the files which we want to move to a server, we copy this file and name it .env.production. Our React build workflow here will automatically pick up this file when we build for production with npm run build, and we'll use the values set up in there instead of these values. So now we can provide different values here. And for example, in the case of the Google API key, we could use the second key here, which is our production ready API key, let's say, and swap our development one for this one. So now we're using that. Now for the URLs, we don't know yet where exactly our backend will be served, right? Because we haven't deployed the backend to any server yet. So we'll leave them like this for the moment, but I will revisit this later once we deployed the backend. Now one last thing you might want to consider for optimizing your front end for production is code splitting. So let me come back to that in the next lecture. You might notice that when we built our application, we got 4 files here in my case, and the biggest file is, in my case, this chunk here with 52.24 kilobytes. Now that is not a problem, this is not too large, but in bigger applications, of course, this might be bigger. And one problem, if you want to call it like this, which we have in this application, in this React application, is that we're not splitting our code. Now what does code splitting mean? It means that not all code is required right from the start. If a user visits our page, he or she might be logged in automatically, or he or she might not be. No matter if that's the case or not, we might not yet have visited the places for one of our users. We might not yet have visited the auth page. So the code that is related to authentication and to user places, or the code which is related to creating a new place or for updating a place, might not be needed yet. It is needed once we visit that page, once we navigate to places new, but not before we do so. And therefore, we could load these routes lazily, which means initially when our app starts, we don't download the code for these routes, but as soon as a user goes there, we download the code on the fly and then render these pages, so that the initial page loading time is reduced because we download less code initially. And React thankfully has built-in support for code splitting. So how do we set this up in React? In the app.js file, I will create a new constant here, one for each route which I want to load lazily. For example, users. And then we can comment out or remove this import here. And users can now be created with react.lazy. And React lazy takes a function. And this is a function which executes import as a function. So import not as a statement like this, but as a function instead. This is also supported in modern JavaScript and also in this React build setup here. And there, we pass a path to the file we want to import. So that path here in the end. Now the difference is that now this is not imported immediately when app.js runs, and therefore in the bundle produced here by our build tool, it's not included right from the start, but it will be loaded on demand once this user component is required, this user's component, excuse me. And we still render this as a regular component. React lazy does the rest. So down there, we don't need to change how we use that. We just change how we import it. And now, of course, we replicate this also for a new place, where I grab this path and use it here. And let's comment this out. Also for user places, where I grab this path here and use it there. And also for update place here, grab this, replace it there. And then I want to do the very same with auth, like this. Now, not all lazy loaded routes I set up here make sense. For example, users is the route we load by default at the beginning, so we don't actually need to lazy load that. We can still do it though. But other routes like new place or update place make a lot of sense because we definitely don't load them initially when the app starts up, so there is no need in loading this in advance. Now, you don't need to use a similar syntax in the other React files because this really only works with the routing here at the moment. And in addition, this is our biggest opportunity for splitting our code into meaningful chunks for the different features of our application. So we only need to do this here in app.js. However, like this, it wouldn't work. We now have to do something else. We have to wrap our routes, which we render in the end, with another component which we get from React. We import it from React, and that's the suspense component. Suspense is required to make React lazy work. So we wrap this here, our routes, with suspense. So your lazy loaded code is wrapped with suspense. And on suspense, you provide a fallback prop. And this has to point at some JSX code which is rendered as a fallback if loading lazy loaded code takes longer. So if downloading that code for that new route the user wants to go to, if that takes longer, React shows the JSX code you render here in between. There we could render a div with a class name of center, let's say, and then our loading spinner. For that, just make sure that you of course also import the loading spinner here. We need to import this from the shared components UI elements folder, and then we can render it here as a fallback if loading of a route should take longer. With that, let's test it locally. So I will use npm start again to build our app for development so that we can test it here on localhost. And let's wait for this application to reload. Now you see, it starts up, I'm logged in, but now something interesting happens. If I clear my network tab, if I go to add place, you see there are new downloads of these chunks. And that in the end are the code chunks that are required for this page. And if we go to authentication, for example, a new chunk was downloaded. So this is the code splitting in action. These are the different code chunks for the different feature areas we have. And therefore now if I quit this and we run npm run build again, we will also see that for production, different chunks are produced. Now the entire when to load what thing will be managed by React. You don't have to worry about that. Therefore, you get a free win here. You got more code files, as you can see. More chunks were created. And therefore, the initial chunk decreased a bit. Now, it's still almost the same size as before, because the majority of this size is actually taken up by the React library itself and by other third-party libraries we included. But still, we're able to get some improvements out of this here. And on bigger apps, of course, the improvements would be way bigger because you would be able to get way bigger chunks out of there. In an app like this, where the third-party libraries make up the majority of the code, of course, you don't gain that much. Still, it is important to know this technique. And with that, I would say our React app is looking quite decent. We're ready to deploy it. And to deploy it, we need to understand which two different options or which two different main options we have for deploying it. When it comes to deploying MERN apps, I see two main options on how you could do that. The first option, probably the better one or the more common one, is that you deploy two separated apps. And with that, I mean that you use two different servers. I will come back to that. The other option is that you deploy one combined app, so all on one server. Now let's have a look at option number one first, so two separated apps. There, your React app and your Node REST API would simply be deployed to different servers or different services which offer hosting. In the combined app case, we change our Node REST API a little bit to not just be a pure REST API anymore, but to also have a route which in the end returns the React app, so that we have both the backend routes, the API routes, and here's the React app route hosted through the same or served through the same Node REST API. Because the React app simply needs a static host, which is why we can deploy it on a separate server, a separate machine. We just need some server which serves our React assets, which is the index.html file, the scripts, and the CSS files statically. No server-side code needs to execute there. We don't need to execute any Node.js code or any other server-side code to serve our React assets. Therefore, we could use a pure static host like AWS Free, Firebase hosting, and many other providers for static hosting as well. You can simply Google for static hosting provider and you will find many examples. The Node REST API, of course, does execute code on the server, and therefore we need a hosting service, a hosting provider that is capable of executing Node.js on the server. And there, from AWS, we could use our own EC2 instance, which is our own virtual server, which we can configure to our needs in great detail, or Elastic Beanstalk, which is a service that takes a lot of configuration out of our hands and makes that easier. Or we use other providers like Heroku, and again, if you search for Node.js hosting provider, you'll find many, many examples. Now, in the right case, where we have one combined app, we just need a provider which is capable of executing Node.js code because, well, we have an app that needs to execute Node.js code. And then in our Node.js code, we need to ensure that for certain requests, we just return our index.html file, our React scripts, and our CSS files. So we will need to tweak our Node.js code for that and then just push it as one app onto some server. Now, I will show you examples for both. One important difference we also will have to adjust in our code is that when we deploy two separated apps, we essentially have the setup we had during development, right? We had localhost 3000 for the React app and localhost 5000 for the Node app. So there, no changes are required. And for example, we need to set these course headers you learned about. Now, if we have one combined app, we need to change something because that's not the setup we used during this course. And then, for example, we could get rid of the course headers because we would be serving everything from the same domain, and therefore the browser wouldn't need these headers to know that access is allowed to the API, because the API would sit on the exact same machine and domain as the frontend does. Now let's have a look at both options, and let's start with deploying two separated apps. Now, as I said, there are many hosting providers. I will start with hosting the Node.js application, and I will use Heroku to host it. A quite popular service, but definitely not the only one. So let's visit Heroku's webpage. And there we can sign up for free, and we can also host the application in the basic requirements we have here for free as well. If you have a real application, you of course might want to check out their pricing and probably choose a different option than the free one, because there you have a lot of limitations. For example, your server goes in sleep mode after 30 minutes of no requests basically, and it then restarts for the next incoming request, which of course makes this specific request a bit slower. And in general, it's great for testing and playing around. For a real application, you will probably need a paid account there. But here we can go with the free one. And once you did sign up, you should see a screen that looks something like this, where you can create a new app. Give it any name you want. Here I'll name it Acad MERN. Choose a region where this will be hosted. For me, US is fine. And click Create App. Now this sets up an app here. You can ignore these steps here. Now for the deployment method, I will use Heroku Git. And that means that you need Git installed on your machine. So in case you're not using Git, Git is a version control system which allows you to control your source code, create different snapshots, and so on. And you can use it for that, and I would recommend using it in bigger projects. But if you don't have it yet, you at least should install it to use it for deploying to Heroku. On the official Git page, you'll learn all about the installation. You can simply download it for your operating system, walk through the installer, and check out the docs if you're having issues with that. It should be pretty straightforward though. Once you got Git installed, you also need to install the Heroku CLI. So we can click on that link to learn how that works. And then just simply download the installer here or run this command. Or for Windows or Linux, use your options, and then simply install that CLI onto your machine as well. So that at the end, you're able to run both Heroku as a command as well as Git as a command in your command prompt or terminal. So then let's run Heroku login first. And I will do this here in my backend project. Simply run Heroku login, go through that login process thereafter. And once you are logged in, continue to the next step. Here, you need to initialize your project as a Git repository and then run this command to basically connect this Heroku app to your local Git repository so that you're later able to push code to your Heroku app and run it there. So let's do that. Let's run git init here in this backend project. Now important, also add a .gitignore file here and ignore node modules. This ensures that when you control something with Git, the node modules folder is not controlled, because uploading this to the backend would take super long, and Heroku will automatically install all dependencies your project needs. It will automatically have a look at package.json and install all these dependencies. So it will create the node modules folder automatically on the backend. So make sure you add this, and then simply run this command here, Heroku git remote, and so on. And once you did this, run these first two commands, and you can provide a different commit message here too if you want, by the way. So let's first of all run git add and then git commit prepared for deployment. Now before we push it to Heroku, make sure that in your package.json file you also tweak the start script here to just node app.js, because Heroku will execute this to then later, well, start your Node application. And we need to also ensure one other thing. Remember these environment variables? They were used by NodeMon. Now we're not using NodeMon on Heroku, we're using Node there. We shouldn't use NodeMon there, it's not a production-ready tool. So these environment variables would not be used right now, they would all be missing. Therefore our app definitely wouldn't work. For example, connecting to the database would already fail because these environment variables at the moment on Heroku simply wouldn't be provided. So to fix this, we have to go to Heroku, can keep this page open, but then here, open this overview part in a new tab. This overview part of your project. There you can learn more about the project. And under settings, you can now set so-called config vars, and these are your environment variables. And here you want to create these environment variables you have in your node.json file as well. So add dbuser here and enter the value you have here in node.json as well, like this. Also add db password thereafter and provide the correct value here. And of course use the value you want to use for production. So if you created a different user for production here on MongoDB Atlas, enter the username and password of your production user here, of course, because these are the values that will be used in production. So db name is the next key I add here. And for db name, I indeed want to use that special database I prepared for production. I named it MERN prod, so I will also name it MERN prod here and click add. The Google API key also should be provided. And here I also want to use my production ready one, which I can quickly get from my frontend here, because there I already did enter it. So this is my production Google API key. Let's enter it here. And last but not least, we need to provide our JWT key value here. And this is my production secret key, or whatever you want to name it. Click add. So now we have all these environment variables set up, and with that we should be able to run our application. At least almost. One thing would still not work. On MongoDB Atlas, keep in mind that there, under network access, we're allowing our local IP address, but not the IP address of our Heroku deployment. And of course, that will be the server who wants to connect to the database in the future. Now, one important thing to keep in mind here is that Heroku uses dynamic IP ranges, and you can learn more about how you could get a static IP here with the help of a certain add-on, or if you have a private space, so a premium paid plan in the end, how you could set up a static IP here. For our local free sandbox environment, I will simply add an IP address here and allow access from anywhere. Now, of course, you could say that's a bit insecure, but keep in mind, this allows anyone to communicate to my database, but that person will still need a valid user and a password for that user. So you still need these credentials. So it's just one extra layer of security which I gave up here, but you could restrict that if you have a static IP. Here in the free sandbox, we just don't have that. So I will open that up to everyone, and once this is done, once everyone can talk to our database, we can finally try deploying this to Heroku. So let's wait for this to finish. So with this finished, let's go back to our instructions here on how to deploy, and let's try this git push Heroku master command here. However, before we push it, make sure you also git add again to reflect your changes to package.json, changed starting script. Otherwise, you will push your old code, your old snapshot, where we still used NodeMon for starting this up. And thereafter, let's try this git push Heroku master command. So this will now deploy this application, will install Node modules there, will automatically detect that you're using Node because you have a package.json file, will build everything, and in the end it will launch your application. Now let's wait for this process to finish here. And with it finished, it gives you a URL where your page in the end is hosted, or where your application is running. Of course, you can also connect a custom domain and so on, and you can learn all about that in the official Heroku docs if you want to do that. With that, let's visit our page here, and eventually you will see that you get an error. Now this error makes sense. If we have a look at our app.js file, we see that we're listening to port 5000. Now this was good during development, but now it isn't anymore. On Heroku, we want to use a different port. Thankfully, Heroku gives you a default environment variable, which provides the port on which your application is served. You can just enter process.env.port here, port all caps, and just use 5000 as a fallback value here. So if that is not provided, we will use this, i.e. during development. If that is provided, which Heroku will do for us, then this will be used instead. And then our application will be served on a port Heroku wants to serve it on, and therefore it will be reachable. So with this, let's add this change, added port env, and then let's repeat this git push Heroku master command. So this will now update our application on the server with this new version of it. We'll replace the old one with it, and we'll start it, of course, and hopefully then it will work. And indeed, if I now visit /API/users, I get back an empty array, which makes sense because we have no users yet in our production database. So our API seems to work, seems to be up and running. Now let's test this with our React app, and let's deploy the React app as well. So let's move over to React, and there, when we build for production, we of course now also want to use our real backend URL. Now we got this URL now, so let's grab it here and insert it instead of localhost 5000, like this. So this is now where our application should be served at in the end, and remove these trailing slashes here. So once we get this set up, we hopefully have a React app which is able to talk to our backend. So let's run npm run build again to create this production build. And then before we deploy this to a static host, I want to test it locally. For that, we need a simple local server which can serve our static assets. And for this, you can search for npm serve to find an npm package which you can install globally on your system to simply serve any static files with it. So here I will run npm install -g serve, and on Linux and Mac you might need to add a sudo in front of this to get the right permissions. And this will now install this serve package. Again, it's just a simple server which we can use locally to serve our build assets. So now cd into the build folder and simply run serve, and this will now serve your production ready React application. So it is a way for us to test this application. It's served on localhost 5000 here. So let's enter that and let's see whether this works. Now it finds no users initially, which makes a lot of sense because we haven't created any. So let's now in the end go to authenticate here and let's try signing up with one. So here I will enter max and pick an image, of course. Here it is. Enter an email address and a password and click sign up. And this seems to work. Here is our user. Now if I click on the user, I could not find any places for the user, but if I try to create one, Marienplatz, a great place in Munich, I'm sure you know this place by now. We can configure all of that, click add place. Now when we go back here, I see we got kind of a strange style here, I would say. If I reload, it's gone, not sure. It's always there when we navigate to this page. Simply a styling issue though, it does work. And we see our place here. We can also view it on a map. Let's try editing it. Looks good. And let's try, before we delete it actually, let's go to MongoDB and have a look into our database to see whether it's stored in the right database, which should be MERN prod. So let's go to MERN prod. And in MERN prod, in places, we have one document with one place, and we have one user. And that user has a reference to our place. And if we now go back here and we delete this place, this works. And if we go back to MongoDB, therefore in the places collection, this should be empty now. And on users, our reference should be gone. And it is. So this works. Our production-ready React app works. It talks to our backend. Now we should be ready to also deploy this React app to a static host. Now, just as for the Node code, there are many hosts you can choose to deploy a static application. I go with Firebase hosting because there we also can get started for free and all we need is a Google account, which we already should have by now. But again, if you search for static hosting, you find plenty of alternatives. Now, you can go to Firebase hosting docs to learn more about it. And as always, you also want to check out their pricing to understand what costs you money and what doesn't. The hosting we will use here will be free, but again, if you're running a bigger application there and so on, then this might not be the case. So how do we host an application with Firebase hosting? For that, we can click on Get Started here on the left, and we learn that first of all, we have to install the Firebase CLI. So just as we had to install a Heroku CLI, we need that, and you can click on your button to simply install it on your system to see the steps you need to run to install it on your system. So simply make sure you do that. You install the Firebase tools here, as it's called, on your system. And once you're done with that, you can run Firebase init. However, and that was part of the installation actually, you also need to sign in. So you need to run Firebase login and log in with your Google account there. So once you ran Firebase login, you can run Firebase init in the project you want to host. So in my case, in this frontend folder here. And there, make sure you're in the frontend folder, not in the build folder anymore. So navigate into the root frontend folder and run Firebase init. Now it will ask you which features of Firebase you want to use, and here we only need hosting. So navigate to that, hit space, and then confirm with enter. Then it asks you whether you want to create a new project or use an existing one. You can choose create a new project here and simply enter a project name into the field once asked for it. Here I will go with an existing one, but you can, as I said, create a new one. As a next step, you're asked what your public directory should be. The default is public, but in our case, the files we want to deploy, and that is in the end what it's looking for here, are in the build folder. So enter build instead. You're then asked whether you want to configure this as a single page app, and you should choose yes here, so that all requests on the server are redirected to that index.html file. As a next step, it asks you that it already found the index.html file, if it should overwrite that, and there you should choose N for no. And thereafter it initializes this, and you should be done. 2 new files are added with the general configuration. And one important note here in the Firebase JSON file is that rewrites entry. In the end, that says for any request sent to your backend server, so whatever URL you're entering there, it will always serve the index.html file because in there we have React and the React router, which parses the URL and then renders the right component. And that's important for single page applications. The location where you're serving them always needs to return the index.html file, that single page you're having, because you're not resolving URLs on the server side, but instead you always want to return your HTML file with your React app in it so that the React app and the React router can do something with the URLs. That's why this configuration is important here. With this configured, if we go back to the docs, we see that now as a next step we can run Firebase deploy. So let's run this command here, Firebase deploy, and this will now push our files in the build folder to a host, to a server provided by Firebase. And once it's done, it will also give you the URL where you find that. Of course, before you run that command, make sure that you ran npm run build with your latest changes applied. I did this already, but in case you didn't, run it first before you deploy. And thereafter, you find your hosting URL. So let's copy that and open it in a new tab. And this is now our application. And you can already tell that it works because it fetched the user I created before. We can also try logging in here. Yeah, that looks good. Still got that strange styling bug here, but besides that, everything is working just fine. And with that, we got our application up and running on 2 separate services. Heroku for Node.js and Firebase hosting for React. And I would say that this is the most common way of deploying such MERN apps. You want to split your REST API from the front end because that REST API you built, which is served through Heroku, really can be utilized by any client. You're not restricted to your React frontend. If you serve this on a standalone server, you can easily connect other clients to it as well. Now, of course, that technically would also be possible if React is served by the same server, but the more you serve from the same server, the more requests hit that server. So splitting the apps on two servers also makes sense from a performance perspective. Users who are just visiting your React app, who are not doing something that hits your database and your REST API, will therefore only hit the static host. And therefore you split the amount of requests and which servers the requests reach. So that would be another argument for using multiple hosts. Nonetheless, in the next steps, I also want to show you how you can deploy everything to one server. Now, before we deploy everything as one app, let's just fix this little styling issue. In the end, we're getting this here from this div where we have the card, which is getting rendered here for our user item here, which applies its own card style, and where we then have user item content, which should override this style. Now, the problem here is that the precedence CSS uses here is such that our card style overrides our user item style here, which should reset the padding to 0. And the reason for that simply is related to the order of styles in which they're imported here into our HTML file. Now, a quick workaround around that is that in user item here on padding, we add the good old important flag thereafter. This allows us to ensure that this definitely gets added. Alternatively, since we know that this will be applied on a card, we could also make our rule here a bit more specific and say this applies when you have a card style combined with that, which would override the raw card style. So the pure card CSS class being added. This is how you could adjust this to make sure that the styling looks the way it should. That, however, was just a minor thing. Still, I wanted to share my thoughts on that here. The main thing I'm interested here is, of course, how we can now make sure that we serve both React Frontend and Node Express Backend from the same server. Because thus far, we were, of course, using two servers. To serve everything from one server, we need to work on our Node application. We need to deploy this onto a host which is capable of executing our Node.js code, for example, Heroku. But, and that's the new thing, we now don't just need to render our routes there, but in addition, now we also need routes that serve our React files. So the single page application we got there in the end. And that is new. It isn't too difficult though. What we need to do in the end is we need to grab our build application. So we still run npm run build here on the React side. We can do that right now to apply our latest style changes. So we still need to run npm run build here, but then we will grab our build folder and copy it over into the backend folder. Though, before we do that, let's double think about our production environment variables in React. The backend URL now will be a different one, or to be precise, it will be the one where our Node application will be served on later. Now, in my case, this is correct here. This is the URL under which I will still serve my Node application later. But if you now want to serve this on a new Heroku project or on a different Node hosting provider, then you need to ensure that you find out which URL you will have after you deployed your Node app and enter this here. So in my case, this should be fine though. So let's now grab the build folder and go back to the backend folder, and there maybe add a public folder and copy everything that's in the build folder. So we'll actually grab the content of the build folder into this public folder here. The name is up to you, but public is the more common name you would choose for that. Now we want to ensure that everything in the public folder is statically served. And we did something similar already in app.js with our images. So in the end, we can copy this line here and add it after, and that's now really important, add it after our routes here. it also means that this middleware here, where we handle unknown requests, is no longer needed, because now I want to say any request going to any URL will be served statically. So here I remove that filter at the beginning, and I want to serve my public folder here, just like this. So what I'm saying here is any request which reaches my backend, which was not handled by these routes, and I need to do this first so that my API still works, but any request that was not handled by these routes will now be handled by this route. And this route will simply return the content in the public folder. So for example, the index.html file. Now, if we rethink this solution, however, it doesn't look that great anymore. Indeed, we would serve everything in that folder statically, and that generally is something we want to do because we want to ensure that, for example, any JavaScript file and any CSS file that is requested from our React app can be served. But, and that's now the problem, this alone is not enough. We can move this back up there actually to our other static serving solution here, so that we simply register this as another static path, where we basically say, if you're requesting something which does not start with uploads images, we'll see if we find a file here and we will serve it. What this unfortunately won't do is it will support our front-end routes. If we are on our running React app and we go to /auth there, so in the front end now, then the request which gets sent to Express is actually that we're looking for an auth folder and by default for an index.html file in there. And of course we have no auth folder here in the public folder. So this works for the initial index.html file, and it works for all the JavaScript files and all the CSS files, so for all the assets we need here, but this does not work for our different routes. To make that work, I will now go to that place after my other routes and use a new one where I want to catch all unhandled requests, because here I now want to set up a middleware function with request response and also next, of course, where I will always return the index.html file. So in here, the idea simply is that I call res send file, and that's a method provided by Express, where I send back a response that is basically made up of one file. And there, I always, for any unknown route, want to send back the index.html file, so that the front-end routing, the React router, can take over and resolve the unknown URL. So here, I want to send that file, and we can build a path for that with path resolve, where the first argument is dir name, so that constant which is available in Node and Express that gives us the current folder of this app.js file. And then we want to go into the public folder, of course, and in there serve the index.html file. That's my idea here. This file should be served. And with that, we should have a setup where we can request any route, and either it's a backend route and these routes kick in, or it's a static file like a JavaScript file, then these routes here or these handlers help us, or it is anything else, and in this case we always send back our single page. Now we can also test this here. We can start up our local server, and for that just make sure that in package.json you also add a script like this dev script which I added here that allows us to still run this with NodeMon. So add such a script, because starting this with Node would not work because that wouldn't take these environment variables into account, and for local development I want to use them, so let's use dev which uses NodeMon, and then run npm run dev to start this Node server locally, and let's see whether that works. And locally, we are using port 5000. We can ignore the fact that this image is missing. We'll take care about this later. But what we can tell is that this works. And if I reload on the auth page, this also is getting served. And if I try setting a request here, so our API should be hit, this also works. We can see in the network tab that indeed we sent a request there. We got back our places here, for example. So we are interacting with the API. So this is working, but in addition to that, serving the React app through that very same Node Express app that hosts our backend API is also working. Now also remember what I said earlier on the slide. When you're serving both from the same host, you can also omit these course headers. So I will comment out this middleware. You can leave it here, it's not a problem, but you can also get rid of it. We don't need it anymore. If I comment it out and I reload here, you will see this still works. If I try to log in again, this still works without any errors besides the image which it doesn't find, to which I will come back later. So this works, and this is now the app prepared for hosting with combined apps where we have Node Express and React in the same project. So with that, we should also be able to deploy this Node.js application. So whenever we have a new version of the React app, we just build it, and then we copy the content of the build folder into the public folder and replace everything in it with it. And once we got that replaced, we deploy our React app here. So how does this work? Well, we use git add again, where we can say added new React app Frontend version, whatever you want to name it. And then we use git push Heroku master again to push this updated Node application to Heroku. And this is basically the same application as before, but it now includes our React application and the logic to serve it. So let's wait for this process to finish now. And thereafter, let's visit this URL again. And if we enter it like this, we should see our application. Now you will notice that the image of the user is missing though, and it was there a second ago. Now I will come back to why that is missing in a second, but let's first of all try authentication and so on, if that works. This seems to work. Let's also try creating a new place. Like we did many times before. Let's click add place here. And this really all seems to work. So why are we not seeing the user's image here? Because in general, the deployment seems to be all right. And that's the important thing. I'll come back to that image thing here in the next lecture. But first of all, let me make it really clear that this is now our app, both the React app and the Node API, served on one machine, on one server, on one service provider, Heroku in my case here. So we got everything on one server, and this therefore is the other option of deploying this. You can use two hosting providers like Firebase or any other static host for React, and then a Node.js hosting provider for the backend, for the Node REST API, or you use one combined setup. It's up to you which one you prefer. Splitting it onto two servers can give you certain performance advantages because requests are split up and not all requests hit the same server. But depending on the size of your app, that also might not really matter, and then you might find it easier to just host everything on one host. Ultimately, it's up to you. I just wanted to show you both alternatives. And now let's find out why this image is missing. This image here is missing because I deployed a new version to Heroku. And the thing is, whenever you do that, it in the end restarts your server, you could say. And with that, I don't just mean the Node process, it restarts the entire machine where your Node app is running on, kind of. Of course, in the end, it uses a system where multiple apps sit on one and the same machine, but your the machine on that machine, so to say, will be restarted. The same, by the way, will also happen if you manually restart it here through your console, of course, or also, since we have the free plan, the same will also happen every 30 minutes. Then it goes to sleep, which means your virtual machine kind of gets shut down. And when a new request arrives, it's restarted. Now, the thing is, the files you upload are not persistently stored on Heroku's servers. Your code is stored and it's simply restarted whenever it is required to, but your other files, like the uploaded images, are not stored. Now, that's not the same for every hosting provider, of course. For example, on AWS, if you rent an entire virtual machine, which you can manage on your own, then files are not lost when you restart it. It really depends on the hosting provider and the exact service, and maybe also the pricing tier you are using. In Heroku's case, if you search for Heroku persistent storage, for example, you'll find a help article where this is explained. And there you also get the recommendation to Instead of storing files on the file system, store files on dedicated static file hosts like AWS S3. And you can also learn how you could adjust your Node.js code to move your files to that host. So that is something you can look into if you choose a certain hosting provider. But again, depending on which provider you are choosing, you might also be on one where this isn't an issue because files are deleted there, because maybe you rented an entire server or something like this. So it really depends on the exact hosting setup you're using. It just is something you also should be aware of. And with that, we're done. You learned how to deploy your application, both separated on two hosts, but also combined on one host, on one machine. And you learned not just how to get it there, but you also learned about environment variables, the difference between development and production mode, how to control your API keys and that you might want to lock them down. And in general, you hopefully now have a good understanding of how you build a MERN application, but then also how you can take that built application, prepare it for production, and then also upload it to a server. And with that, you're well prepared to dive deeper and build your own MERN applications.